Welcome, everyone. This is Dr. Mercola, and today I am joined by Dr. Thomas Seyfried, who has been teaching neurogenetics and neurochemistry as it relates to cancer treatment at Yale University and Boston College for the past 25 years. And he has written over 150 peer-reviewed scientific articles and book chapters, and has also published a book on cancer as a metabolic disease. So we are beyond delighted to have such an expert as yourself, who's really a leader and a pioneer in using diet as a way to address what is one of the most common diseases that is now facing man, and actually one of the most common causes of death. And in some cases, some age groups actually exceeding heart disease as a #1 risk of death. So thank you, and welcome, and thank you for joining us.
Thank you very much.
How did you, I usually find it helpful for our audience to have your frame and perspective on things, and this is not a common area of research and exploration, and I'm wondering what motivated you to start doing research in this area.
Well, we've been doing research in epilepsy for many decades. While I was at Yale and carried it through here to our work on Boston College. And it turned out that the ketogenic diet had been used for quite some time for managing seizures in children. So we were doing a lot of work on brain cancer in mice and epilepsy in mice. And one of my students just thought it would be good to see whether or not ketogenic diets might also be effective against tumors because they were targeting similar energy pathways. So that was back in the late 90s when we started to dovetail our work on ketogenic diets and epilepsy and cancer together at that time. And then it became clear that the mechanisms and the processes were closely parallel to what Otto Warburg had indicated back in the early part of the last century in the 1920s, which then brought us to a better understanding of how this particular metabolic, whole body metabolic change might be effective in targeting and eliminating tumor cells.
Has the clinical medicine accepted the ketogenic diet as a standard of care, or at least a valuable option in the treatment of epilepsy at this point?
Yeah, I served as the organizer for the special interest group for ketogenic diet at the American Society for Epilepsy, American Epilepsy Society. And it was very interesting. We initially started as a small focus group with the folks from Johns Hopkins Medical School, where the diet has had its greatest use and impact. And then we started to grow and substantially increase interest, mainly through the efforts of Jim Abrams, who started the Charlie Foundation for his son Charlie, who had a near-death experience from seizures and was rescued using ketogenic diets, and his colleague Meryl Streep, the famous movie actress, became very involved in this. And now the ketogenic diet is receiving considerable attention in the epilepsy community as a first line of approach. Although this is still not widely accepted, but I have to admit that the ketogenic diet is now recognized as an important component for the management of refractory seizures in children. So it has gained through the notoriety of advocates and various individuals in the setup of a foundation. So the ketogenic diet is moving forward consistently in the field of epilepsy as a non-toxic, effective therapy for refractory seizures.
Are you doing research in this area continued to this point, or have you shifted most of your research into the metabolic control of cancer?
It turns out that the mechanism by which the ketogenic diet manages seizures is, in my mind, not nearly as clear as the way the ketogenic diet manages cancer. So the challenge, of course, is to determine whether it is glucose or ketones that are playing the major role in managing seizure disorders, where we know that it is the glucose reduction that's killing the cancer cells, and the normal cells are now transitioning over to ketones, which protects them from any issues of hypoglycemia.
So you've developed this process called metabolic control analysis, and I wonder if you could describe what that is and how that relates to the treatment and prevention of cancer.
And it's basically a mathematical analysis of very complex integrated network systems. However, when we transition the body from one major fuel source to another major fuel source, there are major flux changes in the homeostasis of these pathways, and that then links the approach to the concepts of metabolic control analysis, which essentially is the analysis of flux through different pathways to maintain global energy homeostasis. So this is certainly in the future will be a very active field in linking how these metabolic therapies are actually managing these complex diseases.
Terrific. And I'm wondering how, many people believe or are under the impression that cancer is primarily a genetic disease, and we've sequenced the human genome, and there's these screens for that, and it presents a lot of fear in many people because they've inherited the cancer gene. So I'm wondering if you could comment on the genetics versus the environmental exposure, and how the foods that we eat can actually control our risk of cancer.
Yeah, well, that's a pretty broad pretty broad question. Let me start off by addressing the issue of whether cancer is a genetic disease or whether it's a mitochondrial metabolic diseases, which I've said in my book. And this goes to the heart, the very heart of the problem in my mind. We're not going to make major advances in management of cancer until it becomes recognized as a metabolic disease. But in order to do that, you have to, at least I did, presented a massive counter argument against the gene theory of cancer. One of the key issues here that if you transplant the nucleus of a cancer cell into a normal cell, you don't get cancer cells. You can actually get normal tissues and sometimes a whole normal organism from the nucleus of a cancer cell. Now, if the tumors are being driven by driver genes and all these kinds of mutations and things that we hear about, how is it possible that all of this is changed when you place this cancer nucleus into the cytoplasm of a cell with normal mitochondria? And the gene theory cannot address this. So it clearly, and I've documented the chapters of my book, these numerous studies that argue strongly against the concept that genes are driving this process. Actually, very few people inherit genes that predispose them to cancer. Most people inherit genes that prevent cancer. And those few genes that are inherited through the germline, like the BRCA1 mutations and P53 and a few other very rare cancers, these inherited mutations appear to disrupt the function of the mitochondria. So the mitochondria is actually the central point in the origin of the disease. Now, the mitochondria can be damaged not only by inherited mutations in those unfortunate rare cases where mutations affect the mitochondria, thereby increasing the risk for someone to develop a particular type of cancer. But what we have is this environmental impact through just living in our environment that damages mitochondria in various tissues. And it's this irritation and damage to the tissue structure that leads to the alteration of function in the mitochondria of those cells, which then go on over a protracted long period of time to develop cancers. So it's ultimately a disease of the mitochondrial energy metabolism, which is the origin of the disease. And I've shown in my book, and others have shown, that once the mitochondria become dysfunctional or insufficient in ability, mutations will occur. So mutations that everybody that in the field that's the focus of the Genome Project, all this, these mutations are essentially downstream epiphenomena of the destabilization of energy metabolism. And this, in my mind, is one of the reasons why focusing on that aspect of the disease will likely bear little, if any, fruit in the long run. So the drugs that have been developed based on the genome projects have been largely ineffective in providing long-term care and are associated with toxic effects. And as long as the field continues to focus on that part of the disease, which is a downstream epiphenomenon, as I have said, there will be no major advances in the field simply because that's not the relevant aspect of the disease.
Would it be fair to summarize a big, large portion of your work as that you've identified that the primary fuel for most cancers is sugar, and that if you restrict their fuel and provide alternate fuels for the person, that you can really dramatically reduce the rate of the growth of the cancer? Is that a fair summary?
Yeah, I think that's a good summary. The problem is the challenge. How to do that, how to implement a particular therapy that would lower blood glucose level. We have to look at it from two perspectives. One is the management perspective, and the other, of course, is the prevention perspective. Um, and these two are hugely different in the way the strategies can be the same, but the approaches can be different. To manage the disease, I mean, we know that there are certain risk factors that will increase risk for cancer. There's certain factors in the environment that will increase our risk, and simply by avoiding those, we can reduce our risk. And as much as we like to talk about these different, perhaps of your focus is on cancer prevention, and I've looked at this, and it's very logical and it's very reasonable. But as you know, many people deal with the disease after they have the disease. They're not really too worried about the risk factors until they get the disease, and then it becomes an issue of management. So when we're dealing with glucose and management, we know from a large number of studies that if respiration of the tumor is ineffective, the cells to survive must use an alternative source of energy, which is fermentation. And we know that glucose is the primary fuel for fermentation. Fermentation is it becomes a primary energy generating process in the tumor cell. So by targeting the fuel for that process, we then have the capability of potentially managing the disease. Although that's easy to say when you look at the overall picture, actually doing this can represent a number of challenges. How to effectively lower blood glucose levels without harming normal tissues in the body. So this is the problem for many cancer therapies, drugs, or whatever you do, you kill the cancer cell, but at the same time you're harming normal cells of the body. So the strategy that we've taken is the use of these low carb, high fat diets, which will then in restricted amounts, and we've done a lot of work on this. If you can lower the blood sugar, and this is an easily measurable parameter, you can just use a diabetic blood glucose meter, and then you elevate these ketone bodies, which we as a species have evolved to burn ketones in the absence of food. We have within our bodies the capability of surviving long term, as long as water is available. We can survive long term from the energy stores within our body. And those energy stores come from fat, which is metabolized to ketones, which is then an effective fuel as an alternative to glucose. So it's a fat breakdown product that can replace glucose as a major fuel for many of the organs, and especially our brain. So the question then is, if that's the case, can we elevate these ketone bodies while at the same time reducing the prime fuel that is driving the tumor cells? The tumor cells cannot use these ketone bodies because of their respiratory insufficiency. So this represents an elegant, non-toxic way to target and marginalize tumor cells. It also allows us to lower glucose levels to quite low levels, because the ketones will protect the body against any hypoglycemia that might be induced by the therapies. So all of the normal cells in the body will be transitioned to these effective ketones, thereby preventing them from damage from hypoglycemia, while at the same time, the tumor cells are now marginalized and under tremendous metabolic stress. So the whole thing is, it's a whole body therapy. So you need to bring the whole body into this metabolic state. This is not to say that certain drugs are not to be used, because we know from our work that if you can get the body into this state, certain drugs which would have been marginally effective when a body would have high glucose and the tumor cells are at their strongest, these drugs now can be used in very low amounts and be highly successful in targeting and killing some of the more resistant tumor cells. So it's a very interesting kind of strategy that, if it's done right and implemented right, can have powerful therapeutic benefits on the majority of people who suffer from various kinds of cancers, because all cancers have the same, primarily metabolic defect.
Yes, and that's a common confusion among a number of people that they believe that cancers, there's one treatment, or that most cancers are similar, even though they're obviously, as we know, very different. But interestingly, they are similar for the fact that they share the similar metabolic pathways that can be utilized to treat them. And let's get into some of the specifics of the ketogenic diet, because I'm sure many people would be interested. Would it also be fair to summarize that for the most part, our body only has two fuels, sugar and fat? And the strategy that you're doing is to lower the sugar that's being consumed and being utilized, and then shifting that over to the fat so that these ketone bodies are generated and primarily used. And would it also be safe to assume that we only have about 6 to 8 hours, maybe 12 hours of sugar stored in the form of glycogen in our muscle and our liver, and then the challenge is to make this transition over to upregulate the enzymes that burn the fat rather than burn the sugar? So I'm wondering if you can go and delve into some of the specific details, that I think it would be really helpful.
We have fat, carbohydrate, and protein. And of course, the proteins can be metabolized to glucose in the liver as well. So proteins can be an energy source. But fats spare protein, which is nice, because if we were to rely on our protein for energy, we would all probably be dead in about a week if we didn't have any food. So fats spare protein, and protein is essential for body function. So the body doesn't start metabolizing protein for energy unless fat is pretty well depleted. I mean, there's a balance. I don't want to be, but the issue here, of course, is that as we transition, fats provide tremendous fat. Fat is basically triglycerides are our storage fuel. I mean, the purpose that this is a fuel that now is called on to provide energy when glucose becomes restricted. How long it takes to burn the stored glucose in our bodies actually can depend on individuals. There's a lot of individual variation in this, because you're right. Our blood sugar is replenished by each meal. Insulin drives the glucose into the tissues, and if the tissues have excess glucose, this will be converted to glycogen and stored in our liver. And if we stop eating, how long does it take to deplete our body of a ready source of carbs?
Well, what factors contribute to, some people may shift from depleting their glycogen stores at 8 to 12 hours, and others up to as long as 36, and that's a pretty big range. I'm wondering what best contributes to that.
Yeah, it's hard to say, because when we try to do this with glucose meters and ketone meters, actually, you haven't eaten for several days, and what's your blood sugar now? Because your glycogen reserve should be depleted, and yet we're still seeing relatively high glucose, like in 85 to something along these lines, 85 milligrams per deciliter. And you say, "Wow, geez, I haven't eaten anything for 3 days. How can this be?" And I've done it on myself and my students. And it turns out how effective gluconeogenesis is. So gluconeogenesis can actually be generating glucose from other sources of proteins and things like this, and maintaining this. And also, when people stop eating, we're learning this now a little bit more from cancer patients. Basically, um, there's a stress. It's overall body stress, and glucocorticoids can be generating glucose from metabolites in the body to maintain a steady level of glucose. So there's a lot of factors, hormonal, emotional, and metabolic, that go into these kinds of transitions. And we're learning more and more that each individual has their own metabolic homeostatic state, and they need to know for themselves by measuring their blood sugars and ketones at what point are they in. We like to call it a new state of metabolic homeostasis, a state where ketones have reached the steady state level in the blood, and glucose has reached the steady state lower level in the blood from before the changes, whether it's either therapeutic fasting, which is water only dieting, or it is a ketogenic diet, or any of these kinds of dietary manipulations. You want to know when your body has achieved a new metabolic state. And basically, we use ketones and glucose as the simplest measures of this new state. We also take blood and we look at lipids and we look at hormones and things like this, but the average person cannot do this. So
What parameters are you looking for with respect to your glucose and ketone levels to know that you've achieved the ketogenic state?
when we see the millimolar levels of ketones are equal to or higher than the millimolar levels of glucose in the blood, because usually in a fed surfeit state, ketones are quite low and glucose is high. So there's a high ratio of glucose to ketones. But in the fasted or therapeutic state, this ratio is actually reversed. So ketones can actually become higher than glucose. Now, most normal people cannot elevate ketones, much higher than 6 or 7 millimolar in the blood. They'll simply eliminate it. Urine will eliminate the ketones. So most people will never reach ketoacidosis. This is a pathological state that's seen in people with type 1 diabetes primarily. So most normal people never reach this state. So what they can do is they can get their blood sugars down to 2.5 millimolar or 3, and their ketones up to 3 or 4 millimolar, where the ratio is now reversed. And it's this state that now brings the body into this new physiology.
Can you translate those numbers to ones that we're more familiar with? This is milligrams per deciliter for the glucose.
Glucose would be about, say, 55 to 65 milligrams per deciliter. And we know we can achieve that just simply if you stop eating long enough, you can get your body into one of these states. Now, it's not, in the morning or in the evening, there will be some flexibility, some fluctuation, but the fluctuations are all within a fairly narrow range. You can shoot up to 90 or 100 occasionally, but milligrams per deciliter. But basically, during the course of the day, the stability of the glucose in and around 55 to say 70. It's not written in stone, but it certainly gives a guideline to the stability. And we found in my colleagues who do the epilepsy and myself, we found that the seizures can be managed quite effectively as long as you can keep that blood glucose low and steady and stable. And this is also the same for the cancer. If you can keep the blood sugar low, stable, and steady, the tumor cells now, which are dependent on this glucose for their survival, are put under extreme metabolic stress. It's how long you can stay in this state. It will just determine how long you can put the pressure. So we've written guidelines to help people understand what these parameters are. And, I find it sometimes surprising that those individuals with type 2 diabetes or even type 1 diabetes who do regular blood sugar monitoring with, finger pricks and blood monitoring. This is part of their daily life. They do this because they know that if they don't, they risk, unconsciousness and various other problems. But for some reason, the cancer patient have generally has more difficulty knowing that this is precisely what they have to do. And it makes it much easier. And they can keep records just like, and they'll know. The problem, with epilepsy, as I've written, when the child or the patient with epilepsy gets off the ketogenic diet or changes, there's a breakthrough seizure. So your lack of consistency is immediately seen, and it's unambiguous. A seizure is very recognizable. Whereas if a cancer patient doesn't see the immediate consequences of falling off this steady state. So that's why we try to get them to measure every day, like the person with diabetes, and then.
Unfortunately, the only major marker they have is death, and that's not a good one. So now you're a PhD, you're not an MD, and you don't treat patients directly. But I'm wondering, is part of your protocol that you advise, do you recommend that cancer patients do this regular monitoring of their blood sugar, and how many times a day do you advise it, and what are the goals that you're looking for, somewhere between the 55 and 70 that you said?
Yeah, 55 to 65, 70, as long as it's low and steady, and ketones are generally in the 2 to 5 millimolar range. It can go up to 7, but I don't see very many people going above 7. It's just very rare. And you also have to recognize that if you become that level in ketose, the fluid elimination becomes a more prominent issue, and therefore salt balances need to be required. This is why these diets should be done with careful monitoring by physicians or qualified health professionals. What I do simply is provide the guidelines that should be followed. But everybody is individual. They have to have a complete physical examination. They have to be told, what to be aware of. So, I work with nutritionists and physicians, and the problem with cancer patients is that many of the practitioners are unfamiliar with this whole approach. So there's this tremendous gap. We have knowledge of how to do this. We have patients willing to do it, but we lack professionals that are trained or even understand the concepts of how to implement these kinds of approaches.
Where are the guidelines that you've compiled? Are they available to the public?
Yeah, in my book, and we've published a couple of papers that outline these guidelines in treatment strategies, oncology. Myself and some of my nutritionists and physician colleagues have co-published articles that give patients certain guidelines, and they're in my book, and it tells you how to do this. And as best we can, and we're learning ourselves more and more how individuals vary in their response to these treatments, and how some of my colleagues from Europe are realizing that not everyone can make this transition readily. Some people require a fine-tuning of the therapy, a gradual transition from one metabolic state to the other. Some people can jump in with both feet, going from a high-carb basic diet into a high-fat diet without any physiological ramifications. Others have tremendous difficulty doing this. They complain of heart pounding or various kinds of physiological effects, which we know are consequences of just the shift from one metabolic state to the other. So this is why it's simple in concept, but much more difficult in implementation. So health professionals need to be involved in this, and it becomes part of their armamentarium to treat the disease, and in knowing that this such and such a person may be a prime candidate for this. And then there are other people where clearly, because of their physiological state, should not consider this as a therapeutic option for their particular cancer and under the condition in which they find themselves. So again, there needs to be a whole training, medical education training, knowing, and this comes back to basic physiology and biochemistry of the body. And also, if one is to use this therapy with medications, one needs to know, what are the adverse effects that might happen if one were to apply a medication at a particular dosage with the metabolic therapy as a concurrent treatment strategy. So clearly, we have a learning curve. We know that this will work, and if it's done correctly, we can see rather dramatic effects. The problem is getting those dramatic and therapeutic effects in a more general way, in a more predictable way, to the majority of the people who would like to use the approach.
Well, one of the strategies we've been advocating for people to get healthier and optimize their body weight is something I'm sure you're familiar with, and I'd just like to discuss how it integrates into your approach, and that's intermittent fasting. Because it's our experience that the vast majority of the public, probably over 99%, are adapted to burning carbs as their primary fuel as opposed to burning fat. And if you could engage in a discipline where you're restricting your calories to a 6 to 8 hour window and having essentially 16 to 18 hours of fasting where you're not eating any food except water, or drinking anything except water, then you're really upregulating the enzymes that are designed to burn fat as a primary fuel and downregulating the glucose enzymes, so decreasing those glucogenetic pathways. So I'm wondering if you found or played with the intermittent fasting as a useful modality to help people make this transition to the ketogenic diet.
Yeah, well, that's basically the way it's started in the clinic for children with epilepsy. Basically the child is given a 24-hour, sometimes it's 48-hour fast, water only, and then the diet is introduced. The ketogenic diet is introduced in relatively measured and small amounts, and the body transitions naturally that way. So intermittent fasting is actually a very strong component of the approach. As you probably well know, and I know very well, there is a blowback against any kind of a fasting or calorie restriction for cancer patients, and this kind of thing, which is largely unfounded when you look at the physiology. But you're absolutely correct. It would be good to 3-day fasting is, as my students and I have said, it's uncomfortable, but it's certainly doable. It gets your body into a new metabolic state, and then you can apply these therapies. The hardest part about this intermittent fasting, and I look at intermittent fasting as a little bit more than 18 hours. I look at it like a 24 to 48 to 36-hour fasting.
Well, how do you implement that regimen? Is that just at the initial phase, or is it something you do on a regular basis?
The hardest part, I think, of this fasting is the first, 3 to 4 days, depending on the individual and how many times they've done this. And that's basically trying to break your addiction to glucose. The removal of glucose from the brain elicits the same kind of problems or events as you would if you were addicted to drugs or alcohol or something like this. You get malaise, you get headaches, you get nausea, you get lightheadedness, you get all the kinds of physiological effects that you would get from withdrawal of any addicting substance. So I look at glucose as an addictive substance. It's an addictive metabolite, where our brains are comforted by having glucose. Our bodies are comforted, and when you break that glucose addiction, you have these particular feelings. However, our bodies quickly recognize that this is only a transient, and that this guy's not going to bring us back to any food. So we're going to now have to upregulate our physiological, our evolutionarily conserved adaptive processes, and then the body becomes into a new state, and that's the state that will put the maximal pressure on cancer cells. And we don't like to keep people in this state too long. Now, how long can you stay in this metabolic state? Even a 7-day water-only fast is still considered intermittent fasting. It's not what we call long-term therapeutic fasting, which is like 15 to 25 days and longer. The healthy young body can fast for up to 40 days if you can. I've seen the evidence for this without pathology. Longer than that, then you enter this pathological state of starvation. Starvation, most people will say that, oh, if I don't eat food for 2 days, I'm starving. Well, believe me, they're not starving. Starving is a pathological state where proteins, essential body proteins, are now digested for the fuel of the body. This is a very unhealthy state, and you can look at blood metabolites and know that your amino acid levels are shifting towards the starvation state. This is completely unrecommended to anyone to do this. So therapeutic fasting is a way, short term, is a way to make the body very healthy over a short period of time, and then the body can transition back to a more normal or a diet with that is what is considered an organically based health diet. But it certainly has very remarkable health benefits to the body, strengthening the mitochondrial network system within the cells of our body. As long as the mitochondria of our cells remain healthy and functional, it's very unlikely that cancer can develop under these particular states. So this is a whole field of physiology that is remarkably healthy, but very difficult to do for the majority of people.
Well, one of the, I actually advocate intermittent fasting as sort of a lifelong approach, and really being proactive to set the stage to hit cancers and other chronic degenerative diseases in an early stage, because I believe that this approach is also helpful for many other diseases than cancer, heart disease, and all these other diseases. So, Alzheimer's, presenile dementia. So one of the things I've noticed, and is really nothing short of a miracle, is that after you've made the transition and you're primarily adapted to burning fat as your primary fuel, the hunger, the desire for these carbohydrates and these junk foods just disappears. Because that's what I believe most people are afraid of and are reluctant to engage in this type of process, is that they know what it takes to deprive themselves, and they don't like that thing. That hunger kicks in, I believe, primarily because they're not adapted to burning the fat. They have to have fuel, otherwise they will collapse, and their body's telling them, go get some glucose or something that turns to glucose real quickly. And that hunger seems to persist until they made the transition. So to me, one of the major benefits is to be more peaceful, more calm, not have to really go out and engage or start consuming food that you know is not healthy for you, because that's the only option available, that you can go for longer periods until you have access to healthy food. So
I agree with you completely, and I put that in the chapter in my book on prevention, which is basically, we're talking about now is basically how do you prevent yourself from getting cancer, and what you're saying is exactly what I've said in the book. As long as you can keep the mitochondria healthy, now which is when you're burning fat and ketones, oxygen-free radicals within the mitochondria go down. Also, there is a stimulation of autophagy. Within the cells, the dysfunctional mitochondria are consumed within the cell, and the biomolecules within those dysfunctional mitochondria are then distributed to the healthy mitochondria and the healthy components of the cell. So we are actually eliminating the dysfunctional mitochondria in placing them with a highly efficient energy system within the cell. And this happens under therapeutic intermittent fasting. So when you're doing this, you're actually, and I agree with you 100%, this not only targets and kills cancer cells, I mean, this makes neurons healthy in the brain to reduce the risk of Alzheimer's disease, cardiovascular disease. This is all linked to the same basic general phenomenon that too much glucose in the bloodstream is not healthy. It leads to inflammation. It leads to cardiovascular disease, which is linked to triglyceride accumulation. It's linked to a lot of things, and it's also linked to dysfunctional mitochondria, which is the origin of cancer. So in certain provocative, you can say this for a lot of diseases, but that it seems to be various ways to cause mitochondrial abnormality in various kinds of tissues. And as long as we can prevent that, individuals should stay a lot healthier. But again, how do you, and we all know this, how is it possible for people to set up a regimen of intermittent fasting during the course of their lifetime to reduce these chronic diseases? And this is, you think about this and we say, well, how, many religions are associated with intermittent fasting. The problem is it's not taken to the level of the physiology. And in the Christian faith, we have Lent, a period of 40 days. Now, most people cannot fast, but you can fast for a week or 4 days, and that would be very, very helpful. And each religion has a period of fast. It's just if they can get they can dovetail these kinds of events in with these kinds of activities, and therefore help them that way. Or people can just try to do this. I agree with you. This is the way to prevent.
Well, I'm glad we're in agreement. And the devil's in the details, so I'm wondering if I can tease some of those details out of you with respect to how this is applied. First of all, before we go into that, though, I'm wondering from a physiological perspective, or if you mentioned the glucose, and we know that that's we believe to be the primary source of the fuel for the cancer, but is the beneficial effect more related to the glucose control, which is really the strategy that most endocrinologists and physicians use to control diabetes, and I think is incorrect. Or is it an indirect assessment? Because if the glucose is low, then your hormonal shifts occur, and then you lower your insulin and leptin levels, which may have more profound implication. And then by lowering the glucose, it's sort of an indirect marker for and easier to measure than optimizing insulin and leptin levels.
Yeah, well, I think that they're both closely connected. So, the insulin goes up when the glucose in the blood is high. The insulin goes down when the glucose in the blood is low. This is the normal, seesaw effect of this whole process. So, sure, clearly, when glucose enters, insulin responds. When there's no glucose, insulin is low. So and glucagon and other hormones are balanced. Let's put it this way. And disease basically involves the problem of imbalance. The hormones are not responding to the metabolites the way they should, and this is due to excessive disturbances in these balances. So keeping this whole system balanced by monitoring glucose, because we know. In diabetes, type 1 diabetes, we'll see tremendous imbalances due to the lack of insulin. So glucose and ketones, that's the terrible state. You have both high glucose and high ketones together in the bloodstream. These are terribly problematic imbalances. And in type 2 diabetes, we have high insulin levels together with high glucose. The body's become insulin insensitive. So again, we have these terrible imbalances.
Well, and that's what I'm referring to, because the traditional physician today, the average conventional approach for diabetes, type 2 diabetes, is to administer insulin because they believe that the bulk of the pathology is related to elevated glucose, not to insulin or leptin resistance. And I think it is beyond a flawed approach, because by giving the patient more insulin, you actually exacerbate the insulin and leptin resistance, and you don't improve it. And you're not addressing the foundational physiological disruption that's occurred or imbalance that's occurred.
No, you're right about that. I mean, I agree with you. I mean, this is certainly what has to be done, and type 2 diabetes can. There's sometimes people get a cure from the gastric bypass surgery. I mean, just you don't have to. You can get. People can change their diet and lifestyle and manage these diseases. The problem is that it's hard to do because of the power of the glucose molecule on the neural functions in our brain that change our behaviors. So these are issues about related more towards the issue of prevention and maintenance of a healthy physiology.
Well, let's go into some of the details. Have you found in your research that there's a significant difference between sugar as a carbohydrate, pure simple sugar like glucose or dextrose or high fructose corn syrup, and sugar in the form of carbohydrates like grains? Have you found that to be a significant difference?
Well, we haven't really looked at that, only because we measure blood sugar and how blood glucose, how that is managed. We've shown strong correlations between the pathology of the tumor in direct relationship to the levels of blood glucose. We've done a number of logistic regression statistical tests trying to link biomarkers to the kinds of changes we see in the pathology of the tissue, like the vascularization, the angiogenesis, the inflammation by NF-kappa B signaling. We're looking at these molecular signaling pathways in relationship to blood biomarkers. And so that gives us an indication of how an individual might respond. And then, of course, we don't have just glucose. There's the glutamine issue, which is a very interesting aspect of this, which is far from being resolved. I think most oncologists who do metabolism, cancer metabolism, recognize that glucose is the prime fuel for driving the tumor. However, we and many others have shown that glutamine and glucose together act powerfully synergistically on the growth of that tumor cell. So these two fuels work together in concert to provide a continual growth of that. So we must think more. Glucose is certainly important and very targetable and effective. But we need to recognize that there are other fuels that will drive this tumor as well.
Well, thank you for bringing that up. I was going to discuss that. Now, glutamine, for those who are watching this or are not familiar with, is a simple amino acid, one of the most common ones, and it's an amino acid as a part of protein. So it sounds like that this dual strategy of lowering the glucose and glutamine are also useful. And how is that practically implemented? Do you just recommend a certain amount of grams of protein per kilogram of body weight or lean body mass, or is there just a simple restriction of glutamine?
Well, you're right about that. We haven't worked on those food sources or diets that might facilitate lowering glutamine. Glutamine is the most abundant amino acid in our bloodstream. So it is of all the amino acids, glutamine is the most. It plays a role in urea cycling. It plays a role in a variety of other metabolic processes. Getting glutamine down with drugs can be done. Phenylbutyrate, buphanyl, is metabolized to phenylacetate, which then binds glutamine, and then glutamine can be excreted. So this has been used for certain rare amino acid disorders. Whether it's been shown to have, that drug has been shown to be effective in certain cancers. Putting this together with a low glucose phenylbutyrate has not been used there's no studies showing this together with these two. It should be done. The problem is the drug is very hard to get and it's expensive. Not expensive relative to some cancer drugs, but it's an orphan drug that's not readily abundant, and it's for the people trying to get this. It's not easy. Are there other ways to lower glutamine? This needs to be further evaluated. We used a drug that blocked glutamine uptake into the cells, and it had powerful effects on systemic metastatic cancer. But at the same time, that drug had some toxicity. So the animals were dying more from the drug toxicity than they were doing from the cancer. So we have to balance and find ways to get around that issue. But the challenge here is another one that most people don't recognize. We've shown that many of these metastatic cancers are derived from macrophages, either stabilized macrophages or fusion hybrids between macrophage and cancer stem cells. The macrophage is the most powerful cell in our body. It evolved to kill bacteria, evolved to reconfigure tissue in hypoxia, in injury and things like this. These cells can phagocytize. Even if we deprive them of glucose and glutamine, this cell can eat another cell in the environment, strip off those fuels, and actually get energy from phagocytizing cells. So here's another issue that people need to be. Those of us who are working in the field are aware. We can do great wonders with these ketogenic diets and do this and suppress the drug cancer, let people live a healthier and longer life. But at the same time, we know that some of those cells can actually hang out in the body and potentially survive by the engulfment of materials within our body, give them the glucose and glutamine that would be deprived in the environment. So, and it's not because the cancers have some magic power. It's because they are derived from a cell that does this naturally, evolutionarily evolved to do this. This is the cell that protects us. And now this cell becomes corrupted. And this is a tough cell to kill. So, but you can kill it through mass action by dovetailing the rest of the body and its demands for certain fuels, thereby further depriving that cell of its energy. These are really heavy, but people need to know that this is what ultimately is going to be required for this disease.
Okay, so I'd like to go into some more of the specifics of the program, at least from your perspective. One of my early mentors is Dr. Ron Rosedale. I don't know if you're familiar with him, but he's done a lot. He taught me about 20 years ago the importance of insulin control, and then more recently the protein issue, which I think might be better than using a drug to lower the protein intake. But it's a sort of a counter to another popular approach to people getting healthy nowadays, which is the paleo approach, and makes sense on a lot of points, specifically from the intermittent fasting. You know, basically our ancestors didn't have access to that, so that seems to be a good, useful tool. And lowering the glucose, they're very clear about lowering grains, anything that would raise your blood sugar. But there are of course two other macronutrients left. One is fat, and the other is protein. And so many of the paleo people really aren't too concerned about high amounts of protein. You know, and according to your research, you know, that could increase the glutamine and most likely will, and that could be problematic. So Dr. Rosedale has found through his research that this pathway mTOR, mammalian target of rapamycin, which is of course an anti-cancer drug, and how this ancient pathway was discovered about 10 years ago, is controlled by lowering your protein intake. So that it could be another metabolic pathway that actually normalizes the cancer growth. And I'm wondering if you can comment on that approach.
Well, we did some studies on this in our glioma model of glioma, and we looked at mTOR. We didn't put it wasn't changing as much as some of the other pathways, like the AKT signaling pathway, protein kinase B, and the HIF-1 alpha pathways, and the VEGF, vascular endothelial growth factor metabolites. The mTOR in our model was not that dramatically changed by these metabolic therapies. So, but I know others have reported it, and this could be an important component for certain other kinds of cancers. But you know, my limited work with this did not demonstrate this to be a major issue, at least in this glioma model that we looked at.
In the glioma study, did you have a low protein intake too, like about 1 gram per kilogram?
Well, we gave them, it was a fast, it was calorie restriction, and you know, this is another issue when we talk about intermittent fasting or calorie restriction. Calorie restriction in the mouse is not the same as calorie restriction in the human. The human is, you know, 7 times lower metabolic rate than the mouse. So therapeutic fasting in the human actually mimics calorie restriction in the mouse. So that's what you're talking about when you talk about intermittent fasting. Water-only fasting for several days is what is comparable to a 40% calorie restriction in a mouse. So when we did diets that had different amounts of carbs or proteins or things like that, it was more or less the amount of food consumed was related more to the issues. I shouldn't say the amount of food consumed; it was related to the caloric intake. So we linked a lot of this to just simply the caloric intake. We showed that you could give animals a high-fat, low-protein diet, and give it as much as they want. Had 0 carbs in this diet. Their blood glucose was just as high or higher than the mice that were eating the protein carb diet. It was more or less related to the total consumption of calories. Calories all most of them come down to glucose. Proteins will be metabolized to glucose. Carbs are metabolized to glucose. Fats are not. The only part of the fat would be the glycerol backbone of the triglyceride, which is conjugated in the liver to make glucose. So even parts of fats can be made into glucose. So the whole issue then became, you know, we don't get any therapeutic benefit either in epilepsy or cancer when we allow the animals or people to eat as much of these high-fat diets as they want. We get no therapeutic benefit. So usually the therapeutic benefit comes from the restriction of the calories of the diet. Now, some people find that these diets are unpalatable, and therefore, well, I eat all I want, but what they want is actually much less than they would normally eat. So it's only because the diet doesn't taste good. And the mice do the same thing. Some of these ketogenic diets, the mice absolutely dislike. And you get this tremendous benefit. You say, oh, look at the mouse ate this ketogenic diet, got all this. You look at his body weight is falling and all this other stuff. And you know that's coming from the reduced caloric intake. But another ketogenic diet, one that's flavored with artificial sweeteners and these kinds of things, the mice eat large amounts of this stuff, and they get all of the health problems and the as diabetics. It makes the cancer grow faster. It doesn't help them at all. So why we use a ketogenic diet or a low carb, low protein diet is simply a way to take the sting out of a therapeutic fast. Because people can, as long as the glucose and ketones can get into the metabolic range, and you can do it with eating small amounts of a fat diet rather than therapeutic fasting, then that just makes people feel a little bit better about how they're doing this rather than feeling that I'm starving to death.
That's interesting. I hadn't heard that before, that the actual calorie restriction was an important part of the equation, and that you really can't go unlimited fat and increase the calories because of what you mentioned, the glycerol probably being converted to glucose. So let's talk about the specific types of fat, and what percentage of fat do you find your patients typically consuming as a percentage of calories? And the types of fats that we recommend are healthy fats. Obviously you don't want to do trans fat. I mean, there's non-controversial at all, but also to limit processed vegetable oils like omega-6s and replace them with more of the saturated fats, and like coconut oil and butter and macadamia nuts, which is also low in protein, and avocados. So if you found that really guiding people on the specifics of the details of the fat and helping them choose healthier ones has made a big difference?
Well, I think this is a very important, definitely a very important point. A lot more research needs to be done on this. The reason why we use medium chain triglycerides, coconut oils, butter, macadamia nuts, and this kind of thing is because they have saturated fats. And the saturated fats are converted to ketones much, much more readily than our polyunsaturated fats. The polyunsaturated fats, like you said, some are good and some may not be so good. So they are less involved in the production of ketones than they are in providing healthy fats for the function of cells. So clearly, again, this whole field needs to be streamlined and better understood as to what fat is going to give us the cancer, allowing their cells to resist hypoglycemia, and what are the fats that are going to be actually necessary for improving the overall health of the normal cells. So again, we need to do a lot more research. Very few studies have been done on combining ketogenic diets with, say, omega-6 or omega-3 fatty acids and these kinds of things to see whether or not we can actually significantly improve the kind of a metabolic approach that we're using to manage the disease. I think this has to be a major focus in the future of knowing how to do this, because I think the knowledge of these kinds of approaches could really be astonishing for improving health. So we're at the very beginning of our quest to manage these complex diseases using natural approaches, non-toxic natural approaches, and we need to know how to balance these to get maximal effect.
What has been your experience when you're recommending these strategies and the research you've done over the past 25 years to clinicians, to oncologists who are actually treating cancer patients? Is there a reluctance? Is there are you seeing openings in the door where they're beginning to adopt these approaches and integrate them with their current therapies?
I think there's a couple of issues in relationship to that question. There are a number of physicians who are realizing that this is a way to improve the health of their patients. What they're looking for is additional information and understanding the concepts and knowing how best to implement this. Then, on the other hand, there is a large, probably a far greater number of individuals, physicians and healthcare givers, who are reluctant to even consider this as an alternative to what their standard practices are. And the reasons for that reluctance, in my view, is just simply the lack of knowledge of the concepts involved in this, and also the lack of training. I don't think a lot of medical schools are training physicians to understand the power of nutritional capabilities and how to actually use that as a tool to manage health. I think there's simply a lack of information and training and education on these approaches, so that we don't have an educated mass of people that know how to do this, and we absolutely need these people because these are the people that will implement, and that's why we have a gap in the concepts and theory and the implementation on the other hand.
Yeah, it's kind of a shocking concept that the fuel you eat that they actually put into your body has anything to do with the outcome of your health. It is kind of tragic that we don't teach that more in med school. So, as a practical strategy, as sort of a summary, most everyone watching this is at a relatively high risk of dying from cancer, but not only that, from heart disease and Alzheimer's. Both of those are in epidemic proportions, and diabetes. So this strategy is sort of a shotgun approach that will radically reduce your risk for every one of those diseases. So I'm wondering if you can summarize your 5 best tips on how to implement this for a preventive strategy.
Well, prevention. I think the work that you've done and the alternative approaches certainly are all in line with improving the overall physiology. Intermittent fasting is a way to prevent cancer. I mean, I think this is clear. Not only cancer, as you said, a lot of other diseases. But you did raise one issue that we need to address. And in the so-called provocative questions from the National Cancer Institute, one of them relates to, why do people with Alzheimer's disease have much lower risk for cancer? And this is, in my book, I addressed the issue only after one of my students, I brought it to my cancer class, and I said, I don't really know why people with Alzheimer's disease would have a reduced risk for cancer. Yet we know that the same preventative strategies would help them as well as the cancer patient. But what is it about them that make them have a lower risk? And it turns out that people with Alzheimer's disease have been documented are hypometabolic. The glucose transporters on their cells are underrepresented. So they can't get the fuel that would drive cancer. Their blood sugar levels are low, so they're hypometabolic. And that represents the easy answer. You can't drive cancer or get cancer if you're hypometabolic. It makes it much less likely. The bigger question that I think is what's making the person with Alzheimer's disease hypometabolic in the first place. And these ketogenic diets and things like this will actually enhance the metabolic efficiency of tissues. So in one case, you need to enhance it to prevent Alzheimer's, and another time you need to reduce it to prevent cancer or target the tumor. So the whole thing has to be viewed in the context of the disease and the metabolic state of the individual. But I think for cancer prevention, I think eating the healthy kinds of foods, the balances, maintaining a metabolic homeostasis that's one related to health rather than inflammation. And inflammation is the culprit linking many of these diseases together. And body inflammation is linked to higher blood glucose levels, and this puts you at risk for all these other. So any health strategy that reduces inflammation, reduces glucose, and these kinds of things will put you at lower risk, not no risk, but certainly lower risk for many of these kinds of diseases, certainly.
Okay, and then the other group of people who we'd like to address is the people who actually have cancer or someone close to them has cancer. And that's a fair number of people. And for those, it would seem from my perspective and what I've learned over the years that it is nothing short of reprehensible medical malpractice and negligence not to integrate this type of strategy into their cancer treatment plan. Now that, anyone can do their due diligence and figure out whatever treatment approach you're going to have, but this can easily be integrated into whatever plan you're going to do. And I just think it is absolutely crucial. There's no cancer that doesn't benefit from treating this, from my perspective, or from my understanding, and perhaps you can elaborate that. But so why don't you address the strategies for them? I think my guess is that the number one approach is to get your book, Cancer as a Metabolic Disease, and start following the recommendations in there and to work and find a enlightened healthcare clinician who can cooperate with you, because you're going to need someone who can act as a coach and help you through that. So, but if you can expand on that and elaborate, that would be great.
Well, this is a very important point. At first, in my view, my personal view is that we can manage this disease. We can prevent the disease for sure. We can manage the disease in those individuals that have it through the metabolic approach. The issue is we need, and I've come to recognize, radiation oncology, chemotherapy, and all this kind of stuff And I agree with you. Some of these are horrific treatments that can do more damage than good in the long run. They're quick fixes to a much more complicated problem. However, I think that uh, uh, dovetailing radiation with metabolic therapy could significantly improve the therapeutic benefits of radiation. Although I'm very much opposed to radiation, I think that when applied together with a metabolic therapy, the outcome would be better. The patient will have less collateral damage, and the therapy could actually have much more significant positive benefit. So clearly, there will be a hybridization. There has to be a hybridization of these approaches for the benefit of the patient. Only in time will it become recognized that we don't need the toxic approach. Let me give you an example. We have a paper that'll be coming out very short from my colleagues and I. They're at the University of South Florida, and I'm here at Boston College, showing how dovetailing the ketogenic diet, the calorie restrict or the mildly restricted diet with hyperbaric oxygen therapy shows powerful synergy. Both radiation therapy and hyperbaric oxygen will create increased oxygen-free radicals, which is which is the design for killing the cancer cells. One does it in a non-toxic way, and the other does it in a very toxic. Now, of course, radiation won't work in a hypoxic environment where oxygen can't get in there to facilitate the killing of the cancer cells with radiation. This is one of the failures of why radiation doesn't work for a lot of the cancers. However, if we can bring the oxygen into the tissues, radiation will work a lot better, but so will hyperbaric oxygen, which is much less toxic. So we know that we can dovetail these approaches together. We know that some of the blockbuster drugs like Gleevec and Herceptin, they target the same signaling pathways that does the ketogenic diet. So why would we take these horrific drugs that they have good benefit, but they also have adverse side effects? But can we get the same benefit without the adverse side effects? I think, or will the drugs work even better at lower doses together with the diet? So again, this is a hybridization of approaches that's only going to benefit the patient in the long run and make their life a lot easier to live and reduce down the side effects from these other kinds of therapies. And then eventually, like anything that happens, there will be in the future a more reasoned transition over to the metabolic therapy as the prime approach to the management of the disease. So, and healthcare providers will eventually come to know this. It's just at this point in time, this is largely unknown.
All right, one last question, and that is on your personal observations and studies. I think it's probably fair to summarize that the current approach, traditional approach, or conventional approach would be a better term for most cancers, is simply cut, poison, and burn. Cut, surgically debulking, which is certainly appropriate. There's no question. I mean, that could save a person's life. Burn would be radiation, and that may be appropriate too, certainly more dangerous. But the poison, or the use of chemotherapy, in my view, and I just would be interested in your perspective, is rarely ever indicated. I mean, that is one, because for the very reason of why it works, it destroys your immune system. As you mentioned and alluded to earlier, we need our immune system to fight the cancer. So you're destroying the very tool your body has to defeat this thing. And even though it may be short-term successful, I think the long-term implications are just disastrous, and in many cases will kill the patient. So I'm wondering if you can comment on that.
Well, I mean, this certainly, and in my book I have a section on it, and I reviewed some of the latest information on some of the so-called targeted therapies and things like this, and you know, the problem here is that they're looking at major advance, you know, cancer being managed, and it's manageable, and we have as 3 to 4 months, 6 months longer survival, and this is you know, this is not the real. This is fantasy land. I don't know what to say. We think the cure is 6 months longer of life, and I don't think this is and it's been shown that these types of drugs, very, very costly with rather significant adverse effects, are not the long-term solution. What's driving this, though, is the genome projects, and this then comes back to the heart of the problem. As long as you think that this is a genetic disease, you're going to persist with these kinds of toxic therapies that have little long-term benefit for the patient. So this again comes to the core of the problem, which is this a metabolic disease, or is it a genetic disease? So I think the shift away from these kinds of targeted chemotherapies will gradually diminish once people realize that this is all a downstream, this is not the core problem. So again, this is going to require an evolution of thought and approaches, and it will take some time. And there's huge financial investments on the part of the academic community and as a part of the pharmaceutical community. The academic and pharmaceutical communities are closely linked in how to deal with cancer. So, but this is often divorced from the real world situation that the patient is dealing with. So we have these large institutional viewpoints on how to manage this disease that are largely ineffective. When the solution to the problem is if you change your view on what the nature of the disease is, you're going to see much greater benefit to patients.
Well, I want to thank you for all your pioneering work in helping us and the medical community come to a deeper and a better appreciation of this foundational concept and everything you've put together so far. So if someone's interested in more specifics, they can certainly pick up your book on Amazon, Cancer as a Metabolic Disease. And do you have a website or any other resource that you could recommend?
We have a Facebook page, I think, on the book that was set up, and my website is at the Boston College Biology Department. So we keep up to date on that. But primarily, those are the major sites on this. You know, and I get so many emails from cancer patients all over the world. And as I said, not being a physician, I cannot recommend any kind of. So what I do is I basically get them in contact with those physicians who can help them and understands the situation, and nutritionists, and that helps these people. But we certainly need more effort into this area.
That's a very good point, and perhaps we can close on that. Is there any list of physicians who know how your approach is and are able to help guide and coach people in implementing that? Is there some compiled list or one that you can recommend?
Well, right now there's not a compiled list, but there are certain physician groups, and I'll be speaking to some of these groups with the hope of explaining better, you know, how they can use their talents and experiences to help implement and better understand the concepts that we're doing, and this then will blossom into a much more concerted effort to do this. But I think physicians are basically interested in the well-being of their patients, and if they can do something to help them and they can see an immediate benefit from this, they're going to be on board with this whole concept. How can this be dovetailed into or integrated into our healthcare policies is another issue. You know, will insurance companies begin to cover some of the costs? One would think the insurance companies would be on board with this. I mean, you can potentially heal patients at a much lower cost, and it's just they would be the ones that I would think would have the most interest in supporting this kind of an approach.
Absolutely. I mean, I think that's one of the reasons. I'm convinced that's one of the reasons why this approach persists, because it's such a lucrative field. I mean, these cancer drugs can be tens of thousands of dollars a month or more, frequently more. And the cost of implementing metabolic therapy, as you've outlined, is a fraction of a fraction. It's probably less than 0.1% of the cost of some of these drugs. So it's essentially not the cost. I mean, the cost to a person to implement this is there really are no costs. It's just your commitment and willingness and dedication to applying these principles, because actually it's even a reduced cost to your food because you're eating less food.
Yeah, I mean, it seems like a no-brainer, but we have a health care crisis. The cost of healthcare in this country continues to rise. I mean, this is the financial well-being of the nation. I mean, we have a major approach that can certainly reduce healthcare costs significantly. I mean, it's unbelievable that we would pursue costly drugs that are potentially toxic when you can get the same benefit from a little education and a little perseverance and discipline. I mean,
well, it's not so unbelievable when you look at the numbers involved. I mean, there's very strong reasons for it that persist, and it is in the process of bankrupting our country. But I believe that's a good thing. I tend to approach life as an inverse paranoid, that when these events that occur seem to be a disaster, as certainly the looming healthcare crisis is, and the destruction of our economy due to the inflation and the printing of money, well, then people become desperate because resources become limited, and then you are forced. You have no choice. You cannot afford these drugs. You can't afford these surgeries. You have to rely on simple strategies that work, and there can't be hardly any simpler and less expensive strategies than when you're promoting for the treatment of cancer. So I think we're going to be forced there eventually because the system's going to self-destruct.
The other issue, too, of course, is that many cancer patients fear the treatments as much or more than they fear the disease itself. And many people are from the complications of cancer. You know, what does that mean? That means that treatments led to death of the patient rather than the disease. So why would one want to do that alternative that you can benefit without putting yourself through that situation?
I couldn't agree more. My girlfriend just had 2 relatives within the last few weeks who were incorrectly diagnosed for cancer, but as a result of that, they said, well, let's give you a preventive treatment, when they both died from the treatments. Yeah. So, and this is not, unfortunately, an uncommon experience. It's it tends to be the standard, it's not the rule rather than the exception. Yeah. All right, well, again, I want to thank you for everything you've done, for everything you will continue to do, and for really being a pioneer in this very innovative, natural approach that really addresses the foundational cause of so many diseases. And I'm really looking forward to see the fruits of your efforts in the future.